I'm going to talk about a software which is the companion for my book Geometric Modeling in Probability and Statistics. It's about this book published with Springer in 2014. This label here, extra materials, means that you can have access to some software. You just click here and then you download the software from there. Now you obtain the software as .exe file. It's called InfoGeo, and then you say more information, run anyway, and we obtain this software. The password here is Springer 2014. Now, to understand how the software works, I have explained it in the Appendix A, right here, and I provide some examples. So it computes entropy, informational energy, cross-entropy, and contrast functions for different sorts of familiar distributions like normal, exponentials, and so on. And I also I have a few examples, and now I'm going to show you how that works. For instance, I want to compute the entropy of one of those distributions, let's say for normal distributions. So I can adjust the mean, I can adjust the scale, I can adjust the standard deviation, large and small. And here there is a entropy computed for this. The formula for the entropy is given by, if you click help, that's the formula for the entropy right here, and that's the formula for the distribution. You can print your thing from here. You can close the window, compute the entropy for any other distribution. Similarly with the informational energy, for instance, information energy for exponential distributions. That's a distribution depending on only one parameter. It's given by this formula. Cross entropy is more interesting. You need to compare two distributions, for instance, two Poisson distributions. So one Poisson distribution is in red, the other one is in blue. There are two parameters for each of those distributions. The cross entropy of those is written here, is 1082. Help produces the definition of the cross entropy, is the integral of the first distribution times the ln of the second. Here there is a button called show level. Let's see, show level, and I want to show the level out of, let's say, 100. Can modify that scale here, and here in green you can see how much of this entropy you get out of 100. So if you make the distribution closer, the entropy should decrease. If the parameters are farther away, then the entropy increases. We also have contrast functions. There are three kinds of contrast functions implemented here: Kullback-Leibler divergence, Hellinger distance, and Chernoff information. The most familiar is Kullback-Leibler divergence, which measures the proximity between two probability distributions. It's not a distance because it's not symmetric and neither satisfies the triangle inequality, but it's pretty useful. So we have two, let's modify the scale a little. We have two normal distributions and we can change parameters for those distributions. The pink corresponds to the red and the blue parameters correspond to the blue curve. Here is the Kullback-Leibler divergence, a Kullback-Leibler divergence which is equal to 0 or very close. It means the distributions are very close to each other. We also have a level we can look at. Let's say the level is out of 1. Click on divergence here. We get very, very little level here. So let's change some of the parameters, then the level goes up because the Kolbe-Gleber divergence increased. Another contrast function, let's say Hellinger distance for, let's say, Poisson distributions. So what does it mean that? Well, go for help, and here is gonna provide that the Hellinger distance squared is twice the integral of the square of the difference of the square roots of the distributions. So it's very similar. You modify the parameters by sliding, or you can type them in. These numbers always have to be into between a minimum and a maximum. So you can modify those if you need. I want to see the level out of, let's say, the level out of 10. And then I can modify and see how the level modifies. So that's another way of measuring proximity between distributions. And Chernoff, that's the most, let's do it for exponential distributions. Chernoff divergence. Divergence stands for a measure of proximity between two probability distributions, is given by this formula. So it depends on more parameters, 3 parameters. So let's see how it goes. We can see a level. We can make the level to be normalized out of 1. Click this, and we start modifying until we get the Chernoff information we actually need. So I have 3 parameters here. Well, that's it. Well, one more thing, this software works as long as you have a PC which has a .NET framework installed, which most of the PCs already come with. Thank you.